Okay. You won't need your computers out anymore. It's hi. So you're going to need your unit circle handy today. Have it out from, how about when you filled it in, the blank one? Okay, I'm going to do, all right. So I am graphing the sine function. The sine function, as you know, we know that sine means like the y values in the ordered pairs, right? So in my unit circle, the sine values are going to be my y coordinate, the second number in the parentheses. So I've got like 0, 1/2, rad 2/2, rad 3/2, 1. So what I do is when I graph this, I pick certain points to plot. I don't really feel like graphing a rad 2/2. Like, I don't know what value that is. So I'm going to focus on the sine values that are easy. Like,
Grant, I don't think you should change your video.
I'm what?
You can't see the screen.
Oh, you can, oh, because my camera is on. Sorry. Okay. So I have this list of ordered pairs, and you're probably like overwhelmed, like, whoa, that's a lot of numbers. Like, what? So we plot the easy sine, which is my y values. So I'm putting little stars by all of the sine values that are numbers that are really nice and graphable. Okay, which means a 1/2. 1/2 in my quadrant 1 matches up with pi/6. My x values are in radians. So here's what I've got. Here's my x-axis. I just listed the, obviously 90 degrees, 180, 270, 360. So I'm giving you, this is the parent function. Obviously my a is going to be 1 because there's no number in front of the sine. My b is going to be 1. The theta also is like my x value, whatever radian I put in. Okay, so we are 7.4, graphing the sine function. So what I'm going to do is these stars are highlighted because they are the easy ordered pairs. As I just said, my x-axis goes in radians. My y-axis goes in whole numbers. Because when you think about it, a unit circle is just a circle. Isn't the unit circle 1 high? And then it goes down -1, right? So that's why I don't really go very high on my y-axis. So let's plot these points. 0, 0 is where the sine curve starts. So I'll plot 0, 0. Then I've got pi/6, 1/2. Well, pi/6, you guys, is 30 degrees, isn't it? So pi/6 is 30 degrees. So it goes in order from least to greatest, like 30 degrees, 45, 60 degrees, 90 degrees, 120, 135, 150, 180 degrees. So pi/6 is 30 degrees. I could say that that's maybe like here, pi/6. Pi/6, comma, up 1/2. Over pi/6, up 1/2. I could say that that's like here, 1/2. Then going to keep going with my black stars. Pi over 2 is given to me. That's fine. That's 1. Because when I'm at, so pi over 2 comma 1, plot that point. When I am at pi over 2, what's my sine value? It's 1, is it not? The y value of my coordinate. At pi over 2, 90 degrees, my y value is 1. Pi over 2 comma 1. Then, I got 2 pi. So if you care to plot it, here's 2 pi over 3. Here'd be like 5 pi over 6, or maybe here. I'm not going to plot every single one. So there's 5 pi over 6. 5 pi over 6 has a x comma y. The y is 1/2. So over 5 pi over 6, 1/2. You guys realize that pi is like 3 away, right? Isn't pi 3.14? And you're probably like, this is really stretched out. Because look at how many dash marks I use. Pi is equivalent to 3. Okay, which means 2 pi is equivalent to like 6 over. So we really are stretching this out. Let's graph pi next. Pi is 0. Pi 0. So I have gone like the upper portion of my unit circle, right? The top half of a circle. Moving on. After pi. 7 pi over 6, negative 1/2. So like, I don't know there. I'm going to write it above because I'm going to run out of space. Negative 1/2. All right. I drop below because now I'm in quadrant 3. Quadrant 3 has negative y values. Quadrant 4 has negative y values. So I have dropped and dipped underneath 0 into negative values because in the y values of sine, they're negative 1/2. Negative 1. 3 pi over 2, negative 1. Plot that point, please. Okay. Then, what's next? What's next? What's next? Oh, 11 pi over 6. Negative 1/2. I don't know, like here, whatever. 11 pi over 6. Negative 1/2. 2 pi, 0. So connect the dots. Ready, ready, ready? I'm going to connect this. It's a very fluid curve. Here was like my upper half of the unit circle. This is like my lower half of the unit circle. This whole movement was an up and a down from beginning to end. That's one cycle. Okay, so there's some things over here I want to talk to you about. My curve. So is everybody done drawing? I want to make sure you're watching me. My curve starts and dips down here. So I'm going to call this, because it's like a circle, isn't it? It's just broken up into two portions. The upper portion, and then I dip into the negatives for my lower portion because it's quadrant 3 and quadrant 4. This is my midline. Now, another word, amplitude. The amplitude means basically from my midline to the highest point. So this one right here, I went up 1. Isn't my unit circle 1 up? Down below. This is my amplitude. Sorry, I'm blocking it. Okay. So my amplitude talks about from my midline to my maximum and from my midline to my lowest, minimum. Okay. Words to know. Amplitude. It's 1. My midline is y equals 0. Now, new word, frequency, or period. Let's do period first. The period means for me to go 1 rotation, how long is it? 1 like cycle through 1 time. Starts at 0, goes to 2 pi. So my period is going to be how far is my cycle? My period is 2 pi. Because from start to end, before it starts repeating, because it's going to repeat itself, this line goes on forever and ever and ever and ever, up and down and wavy line, wavy line. Then my frequency, so my frequency is how many cycles before it starts to repeat. How many cycles before my curve, rotation? It's not a rotation. It's like how many cycles before the shape repeats? How about this? The shape. So, frequency. How frequent does it repeat? Look at this was a cycle. Up, down. That's 1 cycle. Well, it goes 1 time. It ends at 2 pi. So my frequency is 1 time every 2 pi. 1 time every 2 pi. Here's how you write it. 1 over 2 pi. 1 every 2 pi. And this is obviously reciprocals. The period and the frequency are reciprocals. Amplitude. How high or how low does it go? 1. My midline. What's the middle point? The y equals 0 line. My period. How far does this curve last before it starts repeating again? It lasts, it's 2 pi long. It's also a cycle, right? This is one cycle. The cycle is 2 pi long. The period is 2 pi long. The frequency, how frequent does it repeat? Does it zigzag lots? No, it doesn't. How frequent? Well, there's 1 every 2 pi, 1 over 2 pi, 1 cycle every 2 pi. So down below, so I'm going to have you look at the my piece of paper, because I don't want my drawing to go away quite yet. I want my drawing to stay there. My camera's gonna switch, okay? And I'm gonna show you my paper notes. Okay, let's answer 1, 2, 3. Number 1, the period. We already actually filled this out, but what's the period of the sine curve? The period is 2 pi. That's the answer to number 1. Number 2, what's the midline? My horizontal line that's halfway between my max and min. That's y equals 0 line. My amplitude, the distance from the midline to the top, to the max, or midline down to the bottom. 1. Okay. So that's 1, 2, 3. Can you guys all have your cameras on and show me your faces? Because now I can see your faces. And some of you like turn your camera off once I start teaching. All right. So 1, 2, and 3, those are pretty easy. You don't need to copy down all my notes here. Those are just my notes. Now, under my purple line, this is important. This is the parent function. Y or f of x equals a, whatever, there could be a number there other than 1, times the sine of b. Okay, so a is my amplitude. It's always the absolute value that tells me like how high or low I go. And it's always positive because it's distance. It's 1 high or it's 1 low. 1 up or 1 down. So the amplitude is always the absolute value of whatever the a is. The a is the number right after the equal sign. The period I can find out by doing 2 pi over the absolute value of b. If there is a number for b, I can find out the period, how much it takes for this curve to finish its full cycle, 2 pi over b. So make sure you at least have these 2 things written down in your notes. I wrote a lot of like extra stuff, but I verbally said it out loud, so I don't want you to write all these random notes I have. Okay. So I wanted to show you that. Now I want to go to the back, to the second page of this, the next page, because we're going to do numbers 1 and 3 at the bottom of the paper, the sine questions. 1 and 3 at the bottom of the paper. So I'm going to go back. Go back, go back. Right here. Find this. 1 and 3. So my example 1 and example 3, both are sine functions. So I actually have an a and b this time. My A, so I'm doing example 1. My A is 2. My B is 3. And the X is like the angle or the radian. So my parent function was this. And then theta is X because we're going to actually like practice doing a table of values and plugging in today. So my amplitude, just by looking, I'm not even going to graph this one. Just by looking at my equation, I can tell that my amplitude is the absolute value of A, which means it's 2. My period, if you'll remember, is 2 pi over B. Well, that is 2 pi over 3, right? I'll write it bigger. My period is 2 pi over 3. So this graph looks a little different. My midline is still going to be at the middle, y equals 0. So frequency is the reciprocal of my period. 3 over 2 pi. And I'm not going to rationalize the denominator, I'm just going to leave it. So if I were to explain this, I would say amplitude means that it on the graph goes up to 2 on the y-axis and down to -2 on the y-axis. So the curve is a little bit steeper. And the period is that it starts repeating itself after 2 pi over 3, which is 120 degrees. So it doesn't even get to 180 pi. It doesn't even get to 2 pi. All right, let's do example 3. My amplitude is my absolute value of A. So it's 3/4. My period is 2 pi over B. If B was negative, we're not gonna have to worry about that though. 1/3, ready? 2 pi over 1/3. 2 pi over 1/3. Okay, well that can't stay like that. Let's get rid of that 1/3, multiply by 3 over 1, top and bottom. What is it? 2 pi divided by 1/3 simplified, what is it?
6 pi.
6 pi. My midline is still y equals 0. And then it's like, how frequently does it make its full curvature? Ready? Reciprocal of my period. 1 time every 6 pi. Because 6 pi is really far away. 6 pi is like 3 times around the unit circle. Okay, so this is just practicing. If given a function without graphing, can you identify the key features? 1 and 3. We're just doing sine today. Questions so far? All right, let's do some of the homework together, shall we? Would you like to do some of the homework together? We need to practice graphing because, okay, here's what your homework is. Oh, it's on Google Classroom. You all have a copy? So they give you a copy? You need to give you a copy of the homework? That's the notice. Did you graph it? Okay. Take a minute to open it in Cami or print it out or whatever you. Okay. I need my unit circle for this. A is 5/2, B is 2. Okay. Let's plot the points first. Let's not worry about my key features until I actually have filled in my table of values. I chose these numbers for you because they were simpler and the answers were nice, okay? So we're gonna practice plugging in zero. So you're gonna have to put your work wherever you can, you know. 5/2 times sine of 2 times 0. Well, sine of 2 times 0 is sine of 0. So this is basically like 5/2 times 0. Sine of 0 is 0. What's the y value at 0? Plug in pi over 4. Okay. 5/2, which is the same as 2.5, right? 5/2, 2.5, times the sine of 2 times pi over 4. Okay. This is the math right here that I have to actually like use my unit circle for. What is 2 times pi over 4? 2 times pi over 4. Well, 5/2 isn't like the 2 go, sorry. I can cross simplify with the 2 and the 4, or 2 pi over 4. Isn't it pi over 2? Times sine of pi over 2. What's the sine of pi over 2? Unit circle. Pi over 2 is 90 degrees. The sine is my y value in the ordered pair. So my y value in the ordered pair is a 1. So this is basically like saying 5/2 times 1, because sine of pi over 2 is 1. The y value at pi over 2 at 90 degrees is 1. Well, 5/2 times 1, I can make that like graphable, 2.5. So I got 0, 0. Pi over 4, which is like, I could just put it here. Pi over 4 is 2.5. Remember, the sine graphs always starts at 0, 0 and does this over and over and over and over and over again. That's what the sine graph does. Above, below, but it begins at 0, 0. All right. Pi over 2. Pi over 2, I suppose I should make my pi over 4 one space in, because I'm going to have to do Okay. Pi over 2, let's plug pi over 2 in. And obviously I'm writing on top of my, I just see the space. 5/2 times sine of 2 times pi over 2. Two times pi over 2. So diagonally, I cross cancel. 5/2 times, what's sine of pi? What's the y value at pi? Here's pi. Am I doing it right? Yeah. Okay. Well, sine of pi is 0, isn't it? 5/2 times 0. 0. Pi over 2 is back at 0. It's starting to head downward. Whoop. Three pi over 4. 5/2 times sine of 2 times 3 pi over 4. Cross simplify, cross cancel the 2 and the 4. Because you know this is like 2 over 1. You're just simplifying fractions. Or if you like, you can do like 6 pi, 2 times 3 is 6 pi over 4, and then simplify 6 pi over 4. 5/2. Now, sine 2 times 3 pi over 4 is sine of 3 pi over 2. So I'm looking here. What is the sine of 3 pi over 2? That's your unit circle. 3 pi over 2. 270 degrees. Sine means my y value in the order pair. It says 0, -1. It's -1. 5/2 times -1. -2.5. I changed it to a decimal because, so okay. 3 pi over 4 is going to be -2.5. Down here. Sine of pi, I'm sorry, 5/2 times the sine of 2 times pi. This is what I'm doing on my unit circle. What's 2 pi? Or sorry, what's the sine of 2 pi? The y value back at 2 pi, which is like the full rotation, right? So it's 5/2 times 0. 0. At pi, I'm back at 0. Ready? Okay. This is more compact. The 2 is the reason. And I'm already not liking how I did it. But this goes over and over and over and over and over forever and ever and ever and ever. That's the sine function. There is no need to, we're not worrying about left, but it does go to the left too, just like forever. Okay, so we're basically getting the first one done together. Amplitude, peer, frequency, max, min. Key features, key features. This isn't hard. My amplitude is my A, absolute value of A. Oh, my A was 5/2. My period, Remember how it's like 2 pi over b? B is 2. My period is pi. 2 pi over 2. Reduce. Frequency is the reciprocal. One over pi. One time every pi is how the cycle runs. One time, up, down, up. One time, it does that every pi. Every like 180 degrees, every maximum. What's my top point? What's my low point? Max, high, where does it top out at? Bottom, minimum, where does it bottom out at? So I could say it's like positive or negative 2.5. In the other problems that I gave you, I chose the X values for you. I chose X values that were going to produce great Y values, okay? Your task for homework is to do 3, 4, and 5, 2, 3, and 4. This video will be posted, so if you want to look it up, because the numbers aren't going to be 5 halves and 2. You're going to have different numbers. Number 3, let me talk to you about number 3 on the homework. It starts, my A is negative 3. If my A is negative 3, blue, that means it goes downward, right? Isn't that the same for like a parabola? If my A, this is number 3. If my A is, what's my A? Negative 3 sine starts downward. So this is what it looks like. Down. Okay. Keep a heads up for number 3. Let's stop recording.